Total internal reflection by KayScience.com. This is light being shone through a glass tube. At this point, the light is being directed towards the surface of the tube. However, at this point, you can see internal reflection, whereby the light is no longer transmitting through the glass into the less dense air, but instead being totally internally reflected. This here is an optically more dense medium, and this is an optically less dense medium. So this could be glass, and this medium could be water or air. I'm now drawing the normal, 90 degrees to the boundary. This is the incident ray that approaches the boundary. And the incident ray passes from the glass into the less dense air, and it refracts away from the normal. This here is the critical angle. This here is the critical angle. So the reason why the light can refract as it passes from glass into the air is because the angle of incidence is below the critical angle. But not all the light is transmitted from the glass into the air. Some of it is reflected off the glass. So you can see here that some of the light is reflected off the glass, as well as refracting as it enters the air from the glass. So the light will refract because the angle of incidence is lower than the critical angle for that material. So this here is the new normal. This here is the critical angle for this material. So what happens if the angle of incident for the incident ray is the same as the critical angle? As you can see here, the incident ray is at the same angle as the critical angle. The incident ray will now go along the surface of the boundary. And there will also be a lot of internal reflection by the light. So as you can see here, the angle of incidence of the incident ray is the same as the angle of incidence on the critical angle. Therefore, some of the ray is going to pass along the surface of the boundary, and a lot of the light is going to be internally reflected. And this here is the new normal. This here is the critical angle. So this incident ray's angle of incidence is now larger than the critical angle. You can see here that the incident ray's angle of incidence is larger than the critical angle. And now there is total internal reflection. No light is refracted into the other material. So light is shone into this glass tube. The light is shone at the boundary between the glass and the air. The light is passing through into the air, and it is refracting as it passes through. You can see very little internal reflection. At this point, the angle of incidence is less than the critical angle. At this point, you can see some of the light travelling along the surface between the boundary of the air and the glass, and with more internal reflection. At this point, the angle of incidence is about the same as the critical angle. Now you can see even more of the light travelling along the surface. At this point, the angle of incidence is greater than the critical angle. And this is now total internal reflection, because the light is now reflecting back into the glass and not refracting out of the glass into the air. This is total internal reflection. And this is now total internal reflection, because the light is now reflecting back into the glass and not refracting out of the glass into the air. This is total internal reflection.